Hey everyone, and welcome to this explainer. Today, we're diving into the critical final hurdle an operation has to clear before a single drop of oil is reached: onshore rig acceptance. Before any actual drilling kicks off, a rig has to pass an incredibly grueling, unforgiving series of tests. So we're going to take a journey to really understand this process, specifically the critical 5 rig inspections that stand between a safe, efficient operation and, well, total disaster. Think about it like this. Bringing a massive drilling rig on site without a thorough acceptance check is literally like buying a used car and never bothering to pop the hood. Sure, you might get away with it for a few miles, but the odds are definitely stacked against you. Starting drilling operations without rigorous, systematic checks is just an absurd risk when you consider the sheer scale of the machinery involved. But here's the catch. If you ignore the engine of that used car and it breaks down, you're out a few $100. If an onshore rig goes down, oh man, a single day of unplanned downtime can cost hundreds of thousands of dollars. And that doesn't even factor in the total nightmare of delayed well programs, crew overtime, or massive supply chain disruptions. The stakes are just incredibly high right from minute one. So to tackle this incredibly complex machinery, we're going to break the rig acceptance process down into 5 critical pillars: structural integrity, fluid and mud systems, well control, power generation, and finally, safety and sign-off. All right, let's jump right into Pillar 1, structural and mechanical integrity, or, as I like to think of it, inspecting the bones of the rig. When you're dealing with heavy machinery of this scale, a quick visual once-over just doesn't cut it. We are talking about verifying the derrick's API load capacity and closely inspecting the rotational equipment, like the top drive and the drawworks. Something as seemingly small as a bad saver subthread or an overstressed drawworks brake line can lead to a catastrophic structural collapse or dropped pipes. Every single weld, bolt, and wire rope has to be flawless. And all of this intense mechanical scrutiny absolutely has to happen before spud-in, which is just the industry term for the very beginning of drilling operations for a new well. Catching mechanical failures before the drill bit ever hits the dirt is the ultimate goal here. Just an hour spent reviewing a top drive's gearbox oil pre-spud can save literally weeks of unplanned standby time once the rig is fully committed to the hole. Moving on to Pillar 2, drilling fluid and mud systems. This is essentially the bloodstream of the entire operation. You know, it's actually wild how tiny failures in this system can cause massive chain reactions. Just picture a tiny tear in a shale shaker screen. It seems completely minor, right? But that tear bypasses solids straight back into your active fluid system. Suddenly, your mud properties completely tank, you are bleeding money on replacement chemicals, and wellbore stability is totally compromised. To guard against that, inspectors get right in there. They physically check the structural pits for leaks and verify that the agitators are actually preventing barite from settling. But the real kicker here is calibrating the pit volume indicators. If those sensors are off by even a few barrels, you're looking at a massive well control risk. Why? Because you might entirely miss the subtle fluid volume increase that tells you a kick is happening. Okay, let's hit Pillar 3, well control and blowouts. This is the ultimate defense mechanism. When we evaluate the blowout preventer, or BOP stack, against the maximum anticipated surface pressure, or MASP, there is absolutely zero room for error. Every single component, from the annular preventers sitting at the top all the way down to the heavy pipe rams at the bottom, must be brutally pressure tested to handle this exact limit. If a component is rated for 5,000 psi, but the MASP is expected to be 10,000 psi, you stop the rig immediately, no exceptions. But here's the thing. A blowout preventer is just a giant piece of useless iron if you don't have the power to actually close it. That's where the accumulator unit comes in, and its readiness checklist is intense. We're verifying nitrogen precharges at around 1,000 psi, testing the backup pumps, and rigorously checking hydraulic levels. If the rig's main power completely dies during a blowout, this stored hydraulic energy is the solitary way to slam that preventer shut and save the rig. Next up is Pillar 4, power generation and electrical. This is the heartbeat, keeping the rig alive. Now, you don't just flip a switch on these massive generator sets to see if they curr nicely at idle. Proper rig acceptance demands a brutal stress test. All the major loads, the top drive, the mud pumps, the drawworks, are run simultaneously at 100% capacity for 2 to 4 solid hours. We are actively hunting for any hidden capacity issues, overheating, or weird voltage fluctuations well before operations start. Inspectors also have to be absolute sticklers for hazardous area classifications. For instance, in a Zone 1 area where flammable gas is expected to be present, every single piece of electrical equipment has to be completely explosion-proof. If a standard, unclassified light fixture somehow makes its way into a Zone 1, or even if a grounding wire is slightly loose, one invisible spark could trigger a catastrophic explosion. Which brings us to our final stop, Pillar 5, Safety, Environment, and Sign-Off. Think of this as the human and environmental safety net. Because let's face it, perfectly tuned machinery means absolutely nothing if the cruise isn't safe. The physical safety checks here are relentless. Inspectors are out there testing fire and gas detectors with actual target gases and making sure that break glass alarms actually trigger the sirens. They verify that highly specialized H2S escape respirators are fully stocked, unexpired, and, most importantly, immediately accessible right at the point of need, not locked away in some distant closet. And this safety net extends straight to the environment too. A leaking mud pit or a poorly contained diesel tank, that is a fast track to severe ecological damage and immediate regulatory shutdowns. That's exactly why containment berms are aggressively sized at 110% of the largest tank. It basically ensures that even if you have a total, catastrophic tank rupture, the spill won't breach the site perimeter. Now, finding a problem during all these walkthroughs, that's really only half the battle. Just pointing a finger at a leaking valve or a missing permit isn't going to fix it. The rig acceptance process demands that you trace every single issue back to a formal non-conformance report, or NCR, to build a strict, binding corrective action plan. Of course, not all of these findings are created equal, which is why strict prioritization is an absolute must. Take a P1 safety-critical issue, like a failed blow-up preventer test. That halts absolutely everything. The rig simply cannot spud until it is fixed. But say you have a P3 issue, maybe a faded label on a non-critical panel. That can usually be safely deferred with an agreed timeline so operations aren't held up unnecessarily. It's all about calculated risk management. And finally, we reach the climax of the whole ordeal, the sign-off. When a rig is officially deemed ready to go, it requires these staged signatures from the real heavy hitters, the HSE manager, the company man, and the rig superintendent. When they put their pen to that paper, they are taking ultimate legal and professional accountability that the rig is fit for purpose. It's actually a really powerful moment. So there you have it, the critical 5 rig inspections: structural integrity, fluid systems, well control, power generation, and safety. It's a grueling gauntlet, right? Designed specifically to catch the unthinkable before it ever happens. But it leaves us with a pretty provocative thought. In an operation where a single failure can cost lives and millions of dollars, a rigorous checklist is really your only shield. Think about the high-stakes projects in your own professional life. What does your ultimate checklist look like? Thanks so much for joining me on this explainer, and I hope it gave you a whole new respect for the massive undertaking that is rig acceptance. Catch you next time.